Assalamualaikum warahmatullahi wabarakatuh and hi everyone. My name is Wan Nur At-tahirah binti Hasan and I'm from Polytechnic Sultan Salahuddin Abdul Aziz Shah. In this video, I will explain more details about my project.
Today I would like to present my project title, which is a study of development of a smart insole for diabetic food monitoring. So this is the table of content, which include introduction, literature review, methodology, results and discussion, and conclusion. Next is abstract. The foot pressure measurement is important in gait and posture research for diagnosis of foot pressure in athlete, back injury, insole adaptation for orthopedic application, and diabetic foot ulcer prevention. Foot pressure distribution can be measured in a variety of ways. However, patients with diabetic foot ulcer need to wear a special insole that can measure pressure level at a certain points that is suitable for their ulceration. Most of the patients with type 2 diabetes suffering from peripheral neuropathy are at high risk of developing diabetes foot syndrome. A diabetic patient also not aware the condition of their foot that can cause ulceration and nerve damage on their feet, as the diabetic foot ulcer have a greater chance of causing lower limb amputation with the early prevention and intervention. The project proposed to design a smart insole that measure diabetic foot pressure for early prevention of diabetic foot ulcer. The device also consists of an application that will monitor the condition of diabetic foot pressure for patients and doctors. So next is the introduction. As for the introduction, diabetes mellitus is one of the main problems in health system and a global public health rate that has increased dramatically over the past 2 decades. Diabetic patients also have problem with their feet, and also patients with diabetes, even a small wound like a blister because of the tight shoe can cause considerable damage. A high pressure in specific point on feet may increase the risk of ulceration. With developing an electronic in-shoe monitoring system, would be able to track compliance continuously. So as for the objective, to design a smart insole that measure diabetic foot pressure for early prevention of diabetic foot ulcer and analyze patient in monitoring the foot pressure at critical point that have a high risk of ulceration. Next is for the literature review. This is the literature review. There are 3 subtopics in this LR that are related with my project. Number 1 is DFU, which explain about the diabetes patient has foot ulcer that caused by neuropathy and peripheral arterial disease. Second is explain about the patient with foot ulcer will make the ulcer worse, and the pressure from walking can make the infection worse and ulcer expand. Third one is about the smart insole, which can attach with FSR sensor that can monitor pressure. Next is for the methodology. And the block diagram shows the operation of the system in this project. The system can be clearly understood from figure 1, show the block diagram of operating system. There are 3 sections, which is input, process, and output. The main processor of this project is Arduino Nano. The input of this project FSR sensor that is to analyze the pressure from patient foot, and the pressure will be distributed and displayed on the Blink application. A smartphone acts as a platform for an application to the Blink apps in the patient or caregiver smartphone. The power supply for this project is 5 volt. As for the operational flowchart, figure 2 show the flowchart of operational project in developing the smart insole for diabetic foot monitoring. The flowchart show the flow of application of smart insole for diabetic foot system. The process will start with the sense and analyze the pressure from the foot when people are standing on the FSR sensor on smart insole. The Arduino Nano will process the data and send the result via Wi-Fi module for the Blink application, and the result will show in Blink application. Next is this is the equation that I have used. The data were collected in 10 readings, and the average were taken from the sum of the 10 readings from the graph. To test out the average of the reading on foot, the formula is calculated by the average of the reading, as it measures the average reading of the sensor. First, total of the 10 reading was obtained and divided by the 10 as equation below. This part is for the development of a smart insole using Arduino Nano. which program can be loaded from the easy to use Arduino computer program. Next, Wi-Fi module at ESP8266 is the transmission layer of IoT. The function is to convert serial port of TLL level into embedded module, which can converting to Wi-Fi wireless network communication standard with built-in wireless network protocol. Furthermore, the data from the force-sensitive resistor, which is FSR sensor, will transmit to the Arduino Nano and directly sent to the software, which is the Blink application in figure 4. The Blink application is using Wi-Fi. The power bank acts as a power supply for the use to turn on the Arduino Nano microcontroller. Next is for the results and discussion. This is the project design is shown in figure 5, the results of development of a smart insole for diabetic foot monitoring. It used the FSR sensor to detect pressure on foot. The FSR sensor is measured with different location. Objectives are specific measurable insole that are performed to meet the goal, which results in the expected outcome. The results for this smart insole include almost all the same component in block diagram as mentioned before. Overall, this project will be monitoring the diabetes patient on their foot based on the pressure and their situation of their working condition. So next is, this is the results of my technical paper. In order to test the project, two subjectives were chosen from data gathering. Diabetes patient and normal person. Diabetes patient has tendency to get ulcer, while normal person does not. Besides, data is to compare the amount of pressure foot distributed between both of them, where the sensor is located at different points of foot. For sensitive resistor, sensor was placed before their foot, which it will measure from 4 points of their foot. The sensor has been attached to the insole so that the FSR sensor managed to measure accurately and directly from their point of foot. The data also collected has been observed in the situation, which is what condition of their foot. Figure 7 show the analysis of the work situation. As the graph show, the highest pressure can be seen from the FSR2 and which is the metatarsal area, and the heel area, which is the FSR4. The reading for every situation can be seem higher for diabetic patient than the normal person, as this showed that the diabetes patient with foot ulcer have a higher foot pressure compared with a normal person. The graph show that FSR3 and FSR2 are low are due to the gait cycle of walking pattern. The table 1 showed that the data has been collected by using the average formula as mentioned before in the methodology. So as for the conclusion, the objective of the project is achieved. The smart insole has been designed and developed from monitoring device by using application, Blink application. After that, the data of pressure on the foot has been analyzed through the experiments by using FSR sensor. Lastly, IoT is successfully implemented to the project using Blink application. At the same time, by implementing force-sensitive resistor sensor on insole system for diabetic foot, it's helped patients to easily track and better manage about their condition. The project will monitor the diabetes patient who has ulcer and help them from getting worse. This is the reference.
That's all from me. Thank you. Thanks for watching. Bye.